Good morning, everybody. I'm Carolyn from Midwest Manufacturers Association, and I'm happy to see you joining us today for our manufacturing industry webinar series. Today, we're going to be talking about modernizing production planning for small manufacturers. And our presenter is David Altemir, president of Altemir Consulting. I will turn it over to him shortly, but I wanted to let you know that we are recording this webinar, and I will be sending you the recording upon its conclusion. And if you have any questions, please feel free to turn off your microphone and interrupt or enter them in the chat. And we will ask or share that with David when we have a break or a pause in discussion. So from there on, I will turn it over to you, David. And please, like I said, add to the chat and we'll make sure to get your questions answered.
Great. Thank you, Carolyn. Yeah, I'm David Altemir. I'm president of Altemir Consulting. We're a manufacturing consultancy that is headquartered in Dallas, Texas. A little bit about myself. I have 33 years of experience in engineering and manufacturing. Most of that has been in the aerospace industry, including spacecraft, fixed-wing aircraft, helicopters, UAVs. Also spent some time in medical devices doing class 1, 2, and 3 orthopedic medical devices, and have been consulting on my own for the last 8, almost 9 years now, together with 5 other consultants. And so together we serve and support pretty much the entire manufacturing order fulfillment pipeline, starting with customer demand and ending with product shipping out the door. And we do that at the shop floor level and the warehouse floor, doing lean improvements, efficiency improvements. Also in the front offices with doing things like improving purchasing or order management processes, inventory planning, optimization, scheduling, production control, quality assurance, and then we also do some M&A as well. We are specialists in production planning and scheduling, and we're system agnostic. I have personally reached out and touched about 3 dozen or 2 dozen different ERP systems and have implemented nearly 3 dozen. So we work with ERP, with MRP modules, with MES systems, APS systems, and finite capacity scheduling is a particular expertise of ours, which is highlighted in my book, Lean MRP, where we use an ERP. I describe how to use an ERP system to establish a pull system on the shop floor. So it's really a book about production scheduling and production control. But in general, we're specialists in on-time purchasing and manufacturing. So this presentation about production planning practices is really divided into 2 parts. First, I'm going to talk about problems, and then I'll follow that up with solutions. So these are common things that we've seen. We'll start off by just describing what a manufacturing control system, how it's typically implemented. It always starts with customer demand, and customer demand can come to you in various forms. It could be firm customer orders. It could be speculative, as in sales forecasting. It can be based on history. It could be based on forward-looking outlook or any combination of the above. And so when that demand comes in and you get a picture of it, you start planning accordingly. And planning involves what you do for planning materials as well as labor. So that would include inventory planning, capacity planning, production scheduling. I'll throw scheduling in that pot there as well. So your planning and scheduling, once you've got that together, that gives the marching orders for your purchasing department to go buy things, your suppliers to deliver things, and your factory to make things. And ultimately, it's where the product quality is determined. And then you can ship the product out the back door. So that is just a very simplistic conceptual manufacturing control system, I think pretty straightforward and obvious. In practice, there are things that tend to happen and tend to happen quite often. And one of them is that there is a what I call an active management of the schedule. And that's because things change. And so if I represent that change with an oscillator, your customer demand changes. It could be seasonal. Uh, you may not get constant recurring orders. They could be very sporadic and episodic so that you have demand spikes and you have to plan for those spikes or those changes in some way. Um, and so when you execute, of course, because it's a physical process, you're going to deviate from that plan because machines go down, people don't show up to work, they get sick, suppliers take longer than you expected. You deviate from the plan. And so that's what I'm representing here with the amplitude of these two oscillators. Hopefully demand is not changing excessively. I mean, if your customer is changing their mind all the time, that is a problem because it's going to induce chaos into your operation, and that happens sometimes. But usually, it's understandable and legitimate. Uh, they will send you change orders, but the way that's flown into the system and it flows down matters because there can be an amplification effect. And what happens with this active management of the schedule is that you have a feedback loop, and that feedback loop becomes destructive. And so, generally we think we create a plan and we want to work to the plan. But then now, you have to ask yourself, what's the purpose of a schedule? Is it to drive the supply chain or vice versa? And the answer in some cases is yes, yes to both. And that's where it becomes a destructive feedback loop. And then the planning itself becomes an oscillator. And you'll know this is happening right away because requirement dates in your system are changing all the time. And a lot of supply chain managers, purchasing managers are compelled and feel obligated to flow those changes down to the supplier. And of course, that is logical, but it is a problem because that feedback loop is really a chaos machine, and it can lead to inefficiencies that'll manifest themselves as late shipments and high operating costs. And one of the demonstrations I do to illustrate this is I use a spring, and you can see the orange markers here. And so what I do is I shake the spring to represent a supply chain and a segment of supply chain that lives within your factory. And the spring is more than a metaphor. The mathematics that govern the motion of the spring are the same mathematics that are used to model supply chains, even international supply chains and fluid systems and traffic systems. So it's very common in modeling dynamic systems, and it actually is accurate. I've taken empirical data from large manufacturing companies, and it fits this model exactly. So the demonstration is the marker at the top represents your customer order due dates. And then at a lower level, maybe at the first level of the BOM, you would have your top level assemblies or top level sub-assemblies. And then at a lower level, you'd have your manufactured components. And then at the bottom, you'd have your purchase requirements for raw materials. So these are your purchasing people, this is your factory, and then you deliver the product up here. Now, if I start shaking this spring, what you'll notice is that the amplitude down here is much greater than the input. And that's because there's an amplification. And you see this in traffic when you're in a slowdown, is there'll be a little disturbance down the road, and it'll cause gridlock upstream. So that happens a lot. And if this demand is sporadic, then this motion down here can get very chaotic. Now, what does this mean in a practical sense when we're talking about manufacturing? It means your dates change, and more importantly, priorities get destroyed. because down here, if your bombs are deep enough and you have enough operations in your manufacturing routings, then these requirements here can actually be randomized. And I've worked with large aerospace companies, in fact, names we all know, and took measurements, and in fact, they were uniformly distributed, which means random. And so when that happens, you're really operating in a scenario where schedule volatility is getting amplified, and it has effects. So when you operate with a volatile schedule, it's going to drive work in process inventory, which in turn drives longer lead times, and then you have fewer on-time shipments. I'll also add that the collective blood pressure of the organization is much higher in this environment than it is here. And I've worked in both scenarios, and I can tell you this is much better because it's not only better for you and your employees, it's also better for the customers because your control system is self-fulfilling and on-time shipments are assured. Switching gears, another thing that we see is folks will have a perfectly good ERP system, but they'll still insist on working outside of the system. And the most obvious example is purchasing, where they'll use spreadsheets. The buyers will figure out what to buy, how much, and when using a spreadsheet rather than letting the MRP module tell them, give them the correct signals. And that can be for any number of reasons. Maybe they don't understand it. Usually it's because they don't trust the purchasing signals coming out of ERP, which is a shame because modern ERP MRP systems are they're perfectly capable of efficiently and correctly giving buyers purchasing signals. There are other things that are causing the system not to be correct, and it usually has its roots in the quality of the data and the way it was set up, and also training. I'll say that most of our clients that come to us with operating issues, uh, it almost always, or I would just say usually, involves ERP remediation or perhaps retraining in some kind of process optimization of some sort or another. Now, when you use spreadsheets, there certainly are limitations, and the most obvious one is that the spreadsheet is disconnected from the physical operation. Uh, you understand that with an ERP system, with a good manufacturing ERP system, you will be collecting progress reports essentially from your factory and your supply chain so that you know what the status of each order is, you know what the status of each PO and each production order is, and you get that real-time visibility into your operation. And it takes all of the manual management of manufacturing, and it systematizes it in a way through the system so that you can be a lot more efficient that way. Spreadsheets just aren't capable of doing that. You cannot keep uh, inventory accurate on a spreadsheet if you're a manufacturer of any kind of scale. If it's a startup, maybe you want to start out that way, but it won't take long until keeping inventory on a spreadsheet is really not working out at all. And so using the spreadsheet, of course, is not scalable. And in addition to purchasing, inventory planning done on a spreadsheet um, can be problematic. I mean, most folks, when they do inventory planning, they say, "Oh, well, we want to keep these items in stock." The question is how much do we want to keep in stock? And they'll do a spreadsheet calculation. Um, the spreadsheet calculation usually takes the form of X days on hand. They look at how many days on hand of material they have, and it could be, well, we want to keep 30 days on hand, or our rule is we keep 3 months on hand, or they want to get scientific about it, they can look at the lead time for each item and then come up with some way for doing that. But it's compelling to take that approach because it's tractable in a spreadsheet and it's easy to do. But it really is problematic because it doesn't at all take into account supplier performance and demand variation. So I spoke earlier of these demand spikes from your customer. You have to be able to plan inventory to absorb those spikes. Um, so you could do it in a spreadsheet, but uh, it's not the approach or the considerations that most people take. They'll just use a rule of thumb, and when you use those kinds of X days on hand rule of thumbs, it can result in what's called the bimodal inventory distribution, and that's where you take your inventory stock items and you divide them into two groups, the high demand and the low demand. And what tends to happen is that the high demand items, and we can talk either about in terms of finished goods or raw materials. If it's a high demand item, you can't keep it on the shelf sufficiently, and you'll have shortages because they never those stock levels never survive the demand spikes or supplier delays. And if it's low demand, you'll end up with overstock. So you have this situation in which you have shortages coexisting with overstock. And from the point of view of the financial executive, they may look at their balance sheet and say, listen, I don't understand. We have more inventory this year than we had last year. And it's because year after year, these slow runners tend to accumulate because the inventory planning rules are really not optimized. And then, but these are your money makers, and they're a challenge to keep on hand. So the way to resolve this is to use a statistical approach, and we do this. We have a routine where we have an algorithm that we developed to optimize inventory, and every time we use it, almost every time, it's very common for us to have 20 to 40% reductions in inventory while at the same time improving material availability to 100% if that's what the client wishes. So let me say that again. We can reduce inventory at the same time making material more available. So it's usually a very wonderful thing and much needed. Other common issues is when selecting an ERP, saying I want something that specializes in my industry. So, if you're a plastics injection molder, I'm looking for an ERP that is, tailored for that kind of industry. There's usually not a real strong need for that in manufacturing. Most of the name brand ERP systems are sufficiently generalized that they will support pretty much any kind of manufacturing environment. Um, there are differences, uh, but more often than not, I will see, and we get all kinds of, we have ERP systems that we work on that I've never heard of before. And some of them are industry specific, and I can tell that they've been architected and the database is architected in a way that's a little different than an SAP or a NetSuite or uh, most other mainstream ERP systems, and usually it's not for the best. It the generalized systems tend to be better. We just have to align the operation with the system. And the thing is that most ERP systems embody best practices. So if another approach is that the owner of a company, a manufacturing company may say, well, we have our processes here and we're looking for an ERP that's going to support our processes the way we do them. In other words, we want the ERP system to mold itself to our processes rather than the other way around. Um, you have to ask yourself why, because most ERP systems are designed for best practices. So if you want to use the system in a different way or institute workarounds or customizations, why? Because the ERP systems that you can go buy at the store generally support best practices. So perpetuating suboptimal processes is something that you need to think about that may be happening. And when you deviate away from best practices, it means that the system is not used optimally. So uh, there's lots of people that are dissatisfied with their ERP system because they're not using them correctly, or maybe they got a system that really just wasn't right for them. Lack of training also results in the system not being used properly. Um, and I'll mention this, it doesn't apply to everyone, but if you are in a business that makes technical products, or maybe they're large products with large bills of materials, lots of moving parts, um, then an engineering change management process is important. And it's important whether your engineering design function is in-house or out of house. It really doesn't matter. You need a way of conveying those design changes to your purchasing and manufacturing and your supplier base in a controlled way. What is often done is that there is not a real ECM process. What if you find yourself uttering the following phrases? The first phrase would be, um, "We have to scrub the bomb," or you might say, "We're waiting for engineering to freeze the bomb before we start purchasing." Those are symptomatic of a lack of an ECM process or a good ECM process. And it's so important, and I'm harping on it because having good data in your system is essential. And if and the reality is that engineering and production work at different rates. Engineering is always more mature than the production because they are dreaming up the product design. So it's like two trains leaving the station. You don't want them to be completely serial. You don't want to freeze the engineering design before production can take over because then that'll be a very long lead time in terms of time to market and product rollout. You want those two trains to move in parallel as much as possible, and an ECM process is the thing that helps you do it and ensures that your ERP system is working at its best. The other thing that's a common issue is you can't keep inventory accurate, and that's usually speaks to problems with transactional discipline. And I would say 90% of the time it's on the manufacturing shop floor. It's not receiving, or your physical counting process wasn't good enough. It's um, it's that the transition of materials and dollars from raw material to work in process to finished goods isn't really clearly understood, and it's not transacted properly. So let's start talking about solutions, and a good place to start is with a cloud-based uh, planning system. And the reason I say cloud-based is that for small manufacturers, it eliminates all of the IT overhead. Most small manufacturers don't have their own IT department, so it's a way of outsourcing that, keeping the implementation simple. It's a faucet you can just turn on. These are all delivered over the web securely with encrypted data streams and backend databases. So all of that IT infrastructure is taken care of for you because it's web services that are delivered to a web browser. You can easily support remote workers, or if you have multiple sites, if you have workers out in the field with customers, they can access it. And they can access it not only from their office, but as well from a phone. Some of these systems can display quite nicely even on a small screen. And when you have that kind of IT infrastructure behind you, then you have that access to the real-time data, and people are able to collaborate and access the system. So once you've got a system, what's essential for planning is that your master data is it really needs to be A plus, and it's not that hard to attain, but uh, there is a whole uh, lots of tips and tricks and best practices and conventions that should inform how your master data is posed in the system, starting with item master data, part numbering, part descriptions, particularly. Part descriptions, in my view, should always be a mill standard 100 convention. So that people know what the heck it is they're buying and making, everything is easy to read, and it reduces errors and duplicity. Purchasing lead times, very important for driving good signals. And those lead times shouldn't be just what the vendor quoted. It's easy to pick up a phone, call a supplier, and say, "Hey, what's your lead time on this?" And they say 8 weeks, and then you put in your 8 weeks into the ERP system. But in practice, they can have delays. And so these lead times, there's a whole paradigm for managing lead times that will help ensure that purchasing requirements are accurate. MRP ordering parameters, things like reorder points, safety stocks, lot sizes, all of that. There's science behind that. And capacity models, particularly if you're doing finite capacity, uh, specifying the capacity of each of your work centers in a way that really lends itself to accurate scheduling. And so, speaking of scheduling, using finite capacity scheduling is a way of enabling realistic customer commitments to be made right at the outset. And one of the things that we espouse is that when customers send their orders, that there is a process up front where you validate their due dates to make sure that they're realistic, viable, and can be attained. And the buzzword there is capable to promise. So there are some ERP systems that have capable to promise planning and some that don't. Uh, so those two things can help make sure that uh, all the schedules that you're delivering to buyers, to factory workers, and your outside suppliers are realistic so that you don't have to get caught into that feedback loop of active management as I described before. Take advantage of MRP purchasing where it's appropriate. I am totally cool with Kanbans and pull-based systems. In fact, my book is about developing or establishing a pull-based system in the factory. MRP can be part of that. So there's different ways to take advantage of it. All too often, as I described earlier, they don't take advantage of it at all. They just simply use spreadsheets and they do it externally outside of the system. MRP systems work. So it's just a strategy question as to how and where to employ them. And if all of those things are done, then you'll have a body of management data in the system, costs, lead times, inventory, just all of that information will be stored historically, and you can use it to inform a strategic planning process. And usually the buzzword that's associated with strategic planning is SIOP, which means sales, inventory, and operations planning. It's something that big companies do um, where they have a formal process for deciding how much staffing they need. If they need to do capital equipment purchasing, new facilities, efficiency improvements, I would lump that into SIOP. Um, Smaller companies can do their own form of PSYOP. It doesn't have to be overly big or contrived. They just need to use information to inform their staffing and CapEx. So, which ERP system is right for you and will support good planning? Uh, Generally, when you're doing ERP selection, the way I think of it is there's three tiers of ERP, and I think most analysts would take this view. There's a small, medium, and large tier. These would be the Volkswagens and the Boeings would be up here. And then this would be mid-sized companies, and then these would be small businesses. And I just put a couple of logos in here. We could put dozens of logos. There are more ERP systems than I can shake a stick at, but these are just representative. Um, some are better than the others. There are some systems that will not accept a due date in the past, for example. So that puts a real kibosh on doing baseline scheduling for your factory. Um, so there are things to look for and consider, but one thing that's true is the tier one systems can support larger companies, and the tier two can support the tier three companies. Going the other way is difficult because these systems are very big, complex. They have lots of, these are, I mean, after all, these are systems designed to support multinational operations, global finance, lots of different business and legal entities. So there's a lot to them. There's no way to operate these systems for a small business. Even at the tier two, there's a lot of care and feeding that goes into some of these systems that make them um, less than optimum for a small business. But the question is not how many zeros are on your income statement, how many millions of sales. There's no magic spot. It's the operating and business complexity, and do you need that? And like I said, we work with MRP Easy. It is a small business manufacturing ERP system, but it can also support mid-market players and some larger operations. So, what's the best way to unlock efficiency gains? Well, I described using cloud-based system to just simplify ERP ownership. By the way, if you decide you don't like that ERP system or you want to go from a tier one to a tier two or a tier two to a tier three, with a cloud-based system, there's not any infrastructure you have to repurpose. Um, you can just simply migrate your data from one system to another and upgrade that way. So cloud-based makes it simple. Um, Set up your master data correctly as possible. Like I said, a lot of our clients come to us with challenges which in effect end up being an ERP optimization project where data has to be remediated. It's better to have it set up correctly in the first place. But it's never too late. So the data can be remediated in place without being uh, without bothering the operation. Employ best practices throughout the order fulfillment pipeline. So to have the best demand planning processes that you can, the best order management, the best purchasing, the best inventory, the best production control, the best scheduling. That if you make all of those areas in your fulfillment process 10% better, you're going to get more than a 10% return because your supply chain is going to be working harmoniously with itself, and all of those inefficiencies are going to be rooted out, and you'll be able to support customers on time and usually at a lower cost. And then with lower cost, um, the first place you'll see that is overtime, direct labor. So, going back to the bimodal inventory phenomenon and to active management schedule feedback loops, those all things really do manifest themselves in direct labor overtime costs. And as soon as those things are rooted out, that'll be the first place where you'll see the profitability creep in. So that is all I've got. I'm happy to entertain any questions.
Like we have a quiet group today. I don't see anything in the chat as of yet.
Okay, well,
All right.
folks can contact me at any time. There's my info on the screen, and love to hear from them. And good
Yeah.
luck to everyone in the manufacturing industry. Have a happy
And
2026.
yeah, we have you back here in February doing another webinar. So we will make sure that this invitation gets out to everyone who already joined us. And we will see you then. Thank you so much for your time.
Thank you.
All right. Have a good
Bye.
day.